All right, so the notes today have a lot of algebra in them, and so I decided to record them so that it would be easier for you to press pause and then play if there was something that you needed to hear said again or maybe said a little bit more slowly. Okay, you're going to be doing lots of algebra steps, and so I'll explain them slowly to you so that you can feel confident with what I'm doing. But just be mindful of that you might want to press pause today. Parallel lines have equal slopes and they have different y-intercepts. And so it's important that you know that when it says two lines are parallel, parallel does mean that they never cross, which also means that they never intersect each other. But in the graph over here, it's if two lines are on a coordinate plane and if they never cross, it means that they have the same slope. So it says the lines y equals negative 3x plus 4 and y equals negative 3x. Go on ahead and fix this, guys. JK. This is supposed to be minus 2, not plus 2. Y equals negative 3x minus 2. It says that they're parallel. They have the same slope. So this one has a slope of negative 3. This one has a slope of negative 3. But it also says that they have different y-intercepts. If they had the same slope and the same y-intercept, then they would be the same line, and they couldn't be parallel because they would be the same line. They would crisscross everywhere. So in the picture of the graph, they're parallel because they never cross, but they're also parallel because they have the same slope. So it is important that you know that the slopes are the same and that you know that the y-intercepts are different. And so there's two things that need to be true in order for two lines to be parallel to each other. So what we're going to do in examples 1 and 2, it says find the equation of the line that's parallel to y equals 5x plus 1 that passes through the point negative 1 comma 2. So in this example, there's one line that they give you right here, and then you're trying to find the equation of another line. It says that the other line is parallel to this line, so parallel lines mean they have the same slope. And then it also says that they go through the point negative 1 comma 2. And so if it goes through the point negative 1 comma 2, it means that this point, so the negative 1 and the 2, is a point that's on the new line that you're trying to find the equation of. So in order to solve this equation, we have to think about what we're trying to do. I need to know the equation, so y equals mx plus b, because it's a line. I need to know the equation of the new line that I'm trying to find the slope of, trying to find the equation for. So at Steele Canyon, we teach you to draw a BMXY chart. BMXY. And this is just a way to organize the information that you have been given to you in the question. So the B is never filled in because you're trying to find the y-intercept of the new line that you're trying to find the equation for. Your M in this case is 5 because the lines are parallel, so they have the same slope. And then the X is negative 1. And the y is 2 because this is the coordinate of the point that's on the new line that you're trying to find the slope of. Some students, when they're doing this, like to scribble out the plus 1, whatever is the y-intercept of this line, because this is the y-intercept of this line, and you're trying to find the y-intercept of the other line. If they're parallel, these numbers can't be the same. And so we leave the B blank, or you can also write a question mark in here to say that that's what you're trying to find. So I'm going to use y equals mx plus b to find the equation of the line that I'm looking for. In my equation, I'm going to put the 5, just kidding, I'm going to put the 2 for the y, because y is 2. I'm going to put the 5 for m, I'm going to put the negative 1 for x, and then the b stays b, because this is what I'm trying to solve for. So 2 equals negative 5 plus b, and then when I add the 5 to both sides, I get that my b is 7. This is not the answer to the question because they wanted us to find the equation of the line that was parallel to this line. So my answer is y equals 5x plus 7. Notice how the line that I found the equation for has the same slope as the line that I started with. So this one was 5 and this one is 5. But notice how this y-intercept, positive 1, this y-intercept can't also be positive 1 because then they would be the same line. They wouldn't be parallel. So you get a different number there. So you guys, this process is going to work anytime they ask you to find the equation of a line that's either parallel or perpendicular to another line. and that goes through a given point. We've done BMXY charts long ago when we were finding the equation of one line, but here we're finding the equation of a line that's parallel to another line. So you just want to be careful in the directions when you're reading it that you see that it's a little bit different. Find the equation of a line that's parallel to the line y equals negative 3x plus 4. Remember, the plus 4 is not going to matter at all. And then it also tells me that it goes through the point 9 comma negative 6. So on my BMXY chart, it says that the slope is negative 3 because they're parallel. The x is 9, the y is negative 6, and then the b is what I don't know, and that's what I need to solve for. So I'm going to say y equals mx plus b. Negative 6 equals negative 3 times 9 plus b. So I put the y in for the y, I put the m in for the m, I put the x in for the x, and then the b stays b because that's what I'm trying to solve for. And then I'll just go through and I'll finish solving for b. So I'll add the 27 to both sides. And for this question, I get that my b is 21. That's not the answer to the question. That's the y-intercept of the line that's parallel to this line. So my answer for this one is y equals negative 3x plus 21. And that gives me the answer to the question. Notice how they told me in the directions that the line was parallel. And so if you look here, this slope is negative 3 and this slope is negative 3. But notice how they have different y-intercepts. That doesn't mean that as long as your y-intercept is different, it means you got the question right, but that's just how you go through the process of solving it. So perpendicular lines are different. The questions look almost exactly the same. The only thing that's different about the question, I'll use a different color highlighter for this, is that on this one it told you it was parallel, and that's how you know that the slope was the same. But down here, these questions have the word perpendicular in them. Perpendicular slopes are negative or opposite reciprocals of one another. Negative is the same as opposite. So if it's positive, then the perpendicular slope would be negative, and if it's negative, then it would be positive. Reciprocal means that you flip it upside down. So if one of your slopes was negative 3, your other slope for the perpendicular line would be positive 1/3. So there is a little something different you have to do with perpendicular. Look at the picture over here. You can tell right away when you look at the picture that those slopes are not the same slope as one another. One of them's going up, one of them's coming down. So one's positive, one's negative. And then this one's going down really quickly. It's going down by 3/1. This one's going up a little more slowly. It's going up by 1/3. Remember, with perpendicular lines, they intersect to form 4 right angles, and so that's why the slopes have to be different. So when I remember it, I actually remember perpendicular lines have slopes that are, and then I remember the word opposite with the word reciprocals, but you can remember opposite or negative, and you can remember reciprocals or flip. It doesn't matter which way you remember it. Find the equation of the line that's perpendicular to this line that goes through this point. So you're going to use 3, you're going to use -1. You never use the b on this line. But the other thing that I want you to remember when you're doing this is that you're not going to use the number 4. If the slope of this line is 4 and you're trying to find the slope of a new line, the perpendicular slope is going to be, this was positive 4, so it's going to be negative. And then this one was 4, so it's going to be that flip of 4. And so when you flip 4 upside down, it turns into 1/4. So this is the number that I'm going to use when I plug it into my BMXY chart to find the equation of the line that's perpendicular to that line. So you do want to remember when you're practicing this that when it's perpendicular, there's just a little something extra that you need to do. I'm going to use 3 for my x. I'm going to use -1 for my y. And then I'll use -1/4 for my slope. So that's the number that I'm going to use. Just a heads up, this question is a little bit tricky because it works out to have a fraction, but I put it in the notes so that you could practice seeing one that had a fraction. They're not all going to have fractions, so I don't want you to think that anytime it says perpendicular, it means it's going to have a fraction. There's just a little something extra you have to do on this one. So let's see. I'm going to put my y in for my y, and I'll put my m in for my m, put my x in for my x, and then my b stays b. So this one's going to turn into -1 is equal to -3/4 plus b. And then you guys, you have a couple different ways that you can handle finishing solving this. You could just add the 3/4 to both sides, but that requires you to know how to add and subtract fractions, and sometimes students are worried about not being good at that. So what I actually do when I'm solving this is I suggest that students go through and they multiply all of them by 4, because you can always do something to the left of an equation as long as you do it to the right. It makes you have one extra step when you're solving, but more students get this right this way. So if I times this by 4, it turns into -4. If I times this one by 4, the 4's cross out, and so I'm just left over with -3. And then if I times this one by 4, it turns into 4b. If you do fraction busters like this, it's just nice because you don't have to remember how to handle the fraction otherwise. So to get the b all by itself, I'll divide this side by 4 and divide this side by 4. So I'm going to get b is equal to -1/4. It's a coincidence that it's the same as the slope. And then my equation for my line is going to be y equals -1/4 x minus 1/4. Your x and your y, I should have set this up above, your x and your y that you started with here and here don't go into your answer for your equation. So you just use these to find the b, but when you write your equation, it's just x and y. Kind of like up here it was x and y, and then up here it was x and y. So that's the same for perpendicular. It's good for me to point out too that the whole thing is exactly the same, except you just have to put in the different number for your slope. So notice how the slope of this line was 4, so the slope of my line down here is -1/4. This last question is a little bit friendlier for the numbers. So my x is 2, my y is 2. If the slope of the original line is -1/2, then the perpendicular slope, I'm going to change negative to positive, so this will be positive. And then I'm going to flip 1/2 upside down, and when I flip 1/2 upside down, it turns into 2/1, which I can just write as 2 if I want to. Whole lot of 2's in this problem. So here's my BMXY chart. And I'm going to put my x in for my x and my y in for my y and my m in for my m. So it's all 2's on this one. This 2 goes in here. This 2 goes in here. This 2 goes in here. Technically, it doesn't matter which one goes where. And then, oh look, I get another 2. Oops, that's wrong. I'm going to subtract the 4 from both sides, not the 2. 2 take away 4, well, I guess it's -2. And so on that one, I get that my b is -2. And so when I write my equation to the line, for the line, it's going to be y equals, my slope was +2, and then my y-intercept was -2. And so you guys, if you graphed this line, and if you graphed this line, they would look something like this. One of them would be going up, one of them would be coming down, and they would intersect to form 4 angles that are all 90 degrees. And so that's how you find the equation of lines that are perpendicular to each other, but also how you find the equation of lines that are parallel to each other.